This is a vodcast with an example of how to calculate a rate law, a specific rate constant, and the orders for a reaction where there are two reactants in the chemical equation. You can see by this example that you have A plus B making C, so there's two reactants, and you're given experimental data where you're given the concentrations and you're given the rate of the reaction. There were 3 experiments that were taken and accounted for. I'm asking you to write the rate law for the reaction and to find the value and units of the specific rate constant. So that means you have to calculate K and you also have to calculate the orders. In this case it would be N and M. The rate law, since it has 2 reactants, is stated as rate is equal to K times the concentration of A to the nth power times the concentration of B to the mth power. And that could be, if you had 3 reactants, you would have another term right in here, although that won't happen for you in this class. So when you look at this data, you'll notice that you have some experiments where the experimenter gets to control the concentrations. They controlled a constant concentration for experiments 1 and 2 for the reactant A, and the concentrations changed for reactant B. And if you look at experiments 1 and 3, you'll notice that they stay constant for reactant B and they change for reactant A. We're going to use this data to solve this problem. So looking at the next page, and we have our rate law here. Rate is equal to the specific rate constant times the concentration of A to the nth power times the concentration of B to the mth power. As we look at our data and we're going to compare our ratios just like we did in our first example problem earlier, I have my rate law. I'm going to compare experiment 1 over experiment 2. As I've said before, that's going to give us larger positive values, which is what I find easier to work with. So here I've got 8 times 10 to the negative 8 molarity squared is equal to the K times the constant 1.2 molar solution of A times 2.4 molar solution of B to the mth power, and I'm going to compare that to experiment 2, which is 4.0 times 10 to the negative 8. The molarity over seconds is equal to K times 1.2 capital M to the nth power times 1.2 capital M to the mth power, which is the concentration of B. Notice, just like in the earlier problem, the rate constants by definition is a constant, so that's the same value. They're going to cancel out, and so does the concentration of A. Since it's both 1.2 molar, they cancel each other out. So we can then simplify this term. 8 times 10 to the negative 8 divided by 4.0 times 10 to the negative 8 gives us a 2. And when we take 2.4 molar divided by 1.2 molar to the mth power, we get 2 to the mth power. Therefore, M is 1. And we say that this reaction is first order with respect to B. Secondly, we're now going to compare reactions, or experiments I should say, 3 and 1. When we compare experiments 3 and 1, you will notice that B, the concentration of B, remains constant. So now I take the rate is equal to K times 3.6 molar, this is experiment 3, to the nth power times 2.41 to the mth power, first order, which we already established, over 8 times 10 to the negative 8 M over S, molarity per second, is equal to K times 1.2 capital M molar to the nth power times 2.4 M to the 1 power. This is constant as well as the K. Simplifying, this becomes 9 and this becomes 3 to the N. N then equals 2, and we say the reaction is second order with respect to A. So now if I asked you to write the rate law, oops, When I ask you to write the rate law in terms of order, you can say that rate is equal to the specific rate constant K times the concentration of A to the second order times the concentration of B to the first order. If I asked you what is the overall order, the overall order is the sum of the individual orders. So in this case, it would be 3. Finally, I'm going to ask you to find the value and the units of little k. And to do that, you're going to plug in one of the experimental values into the rate law expression. And I chose experiment 1. So here you go. I've got 8 times 10 to the negative 8 molar, that is the rate, is equal to K times 1.2 molar squared, because it's second order, times 2.4 molar to the first order. Now, as I simplify this, I take this term and I ended up simplifying it, and I found that it's 3.456 m cubed, because look at this is m squared, because it's 1.2 times 1.2 and m times m, and then I'm also going to multiply that times 2.4m, which becomes m cubed. Here I am simplifying to get x, or isolating x by itself, and when I do that, I can cancel this m and one of the m's in the denominator, as you can see over here. As I simplify that, you will notice that I get a value of little k is equal to 2.3 times 10 to the negative 8, and the unit is s to the negative 1 capital M to the negative 2, or it could be written as 1 over s 1 over capital M squared. That's how you solve a rate law problem when there's two reactants.